Today's lesson is going to focus on what we call impulse. Impulse, a quick way to think about it is how you can extend the amount of time a force is being applied on an object. Well, so in sports, we use this idea in order to extend the amount of power we give something, such as in basketball, when you shoot, you want to follow through and extend the amount of time that the push that you give the ball is on the basketball, which maximizes where the ball goes. In tennis, we would do the swing. As you're swinging, you want to follow through completely so you can maximize the amount of time the racket is on the ball. So in science, we define this as being how fast an acting a force is exerted over an object. So how fast acting a force is on an object is known as impulse. The formula is impulse, which units are Newton seconds, is equal to force in newtons multiplied by the change in time, which is in seconds. So our impulse units would be a Newton second, where this change in time would be whatever time final was minus the initial time. In other words, how much time it actually spent on the object. So we have our J is the symbol for impulse, and this little triangle here is the Greek letter delta, which means a change in something or whatever. So we have the impulse that is actually causing the object to move. We just learned in Newton's first law that an object at rest stays at rest. Well, impulse is what acts on the object and allows it to start moving because it's going to change its position, which gives us a force and how much time we exert the force. Now, once we've exerted a force on an object, we call what we say momentum. Momentum is a measure of how difficult it is to stop a moving object. Again, Newton's first law says an object in motion stays in motion until an outside force acts on it, or an unbalanced force acts on it. Well, once it's in motion, we call that momentum. And momentum can be calculated by taking the mass in kilograms and multiplying it by its velocity. Now remember that velocity is a vector, therefore momentum will have a vector, meaning it's going to have a direction involved. And that's why that little line is above it, because these are vectors. Mass, remember, is not a vector, but it still is involved, so the overall momentum is a vector. So we definitely have to account for direction of which the object is moving or has stopped moving. So this funny looking letter is the Greek letter rho, and that's what we use as our symbol for momentum. Derived the calculation of momentum. So previously we talked about impulse. Well, impulse acts on an object and it will give, it'll start its motion, which will give it momentum, and then we need another impulse to stop our momentum as well. Now we can redefine impulse as to how much force changes momentum. How much force is needed to change the momentum of the object. So impulse can equal the change in momentum. So if the object was originally stopped and then we gave it an impulse to give it momentum, we can put these together and calculate our impulse. We can also use the equation, obviously F multiplied by change in time, which was impulse, and set it equal to the change in momentum. And so at the end, force times time, the change in time, is equal to mass times the change in velocity. So this would give us an indication of how much impulse was required to change the momentum of an object.